Welcome to ArXiv Preprint Server Daily, AI Frontiers, where we explore the latest cutting-edge research in artificial intelligence. Today we're diving deep into the field of computational linguistics, examining the most significant recent developments and their implications for the future of language technology. In this comprehensive exploration, we'll identify key research themes, analyze groundbreaking findings, examine methodological approaches, and highlight particularly influential papers that are shaping the direction of the field. Computational linguistics sits at the intersection of computer science and linguistics, focusing on the computational modeling and processing of human language. This field encompasses a wide range of research areas including natural language processing, language understanding, generation, translation, and the development of language models. The significance of computational linguistics cannot be overstated in today's technology landscape. It forms the backbone of many applications we use daily, from virtual assistants to machine translation services, content recommendation systems, and increasingly sophisticated text generation tools. The current era is dominated by large pre-trained language models that learn from vast amounts of text data and can be adapted to a wide range of specific tasks. These models have achieved unprecedented performance on various language understanding and generation benchmarks, but they also face limitations related to computational efficiency, reliability, and domain specificity that researchers are actively working to address. The first major research theme we observe is multimodal language processing, which involves integrating multiple modalities, particularly speech and text. A significant trend in current research involves developing systems that can seamlessly process and generate information across different modalities. The VITA-Audio model introduced by Long and colleagues represents a prime example of this trend. This model addresses a critical bottleneck in speech-based systems, the high latency when generating the first audio token during streaming. By developing a fast interleaved cross-modal token generation approach, the researchers achieved an impressive 3-5x inference speedup at the 7B parameter scale while maintaining or improving performance on speech recognition, text-to-speech, and spoken question answering tasks. This multimodal approach reflects the growing recognition that human communication is inherently multimodal, and AI systems should be capable of processing and generating information across different modalities seamlessly. The second dominant research theme focuses on efficiency and optimization in large language models. As language models continue to grow in size and complexity, researchers are increasingly focused on making them more computationally efficient without sacrificing performance. Several papers address this challenge through various approaches. For instance, in faster LLM inference for extremely large models, Yang and colleagues explore optimization techniques for mixture of experts models, particularly focusing on fine-grained MO architectures. They demonstrate that reducing the number of activated experts can lead to substantial efficiency improvements with only minor performance degradation. Similarly, the paper Long-Short Chain of Thought Mixture Supervised Fine-Tuning by Yu and colleagues addresses the overthinking problem in reasoning models, where they produce verbose and redundant reasoning chains. Their approach combines long chain of thought reasoning datasets with shorter counterparts, resulting in models that maintain high accuracy while substantially reducing response length by approximately 47.61%. These efficiency-focused papers highlight the practical challenges of deploying increasingly large and complex language models in real-world applications. The third research theme we identify is domain-specific applications, with a particular emphasis on healthcare. A significant portion of the papers focus on applying language models to specific domains, with healthcare emerging as a particularly important application area. Papers like Uncertainty-Aware Large Language Models for Explainable Disease Diagnosis by Zhou and colleagues and Lightwave Clinical Decision Support System using Chlora-fine-tuned LLMs and retrieval-augmented generation by Ansari and colleagues demonstrate how language models can be adapted for medical applications with significant potential impact. The paper Med-Arabic by Abu Daoud and colleagues addresses the specific challenge of applying language models to Arabic medical tasks, highlighting the importance of developing multilingual capabilities in specialized domains. These papers reflect the growing trend of adapting general-purpose language models to specific domains where they can provide practical value, while also highlighting the challenges of doing so effectively and responsibly. The fourth research theme centers on evaluation methodologies and benchmarks. As language models become more capable and are deployed in increasingly complex scenarios, developing robust evaluation methods becomes crucial. Several papers focus on this challenge, introducing new benchmarks and evaluation frameworks. WebGen Bench by Liu and colleagues introduces a benchmark for evaluating an LLM-based agent's ability to create multi-file website code bases from scratch, with automated testing to assess the functionality of the generated websites. This moves beyond simple accuracy metrics to evaluate performance on complex, real-world tasks. Similarly, Say It Another Way by Chad Hayner and colleagues proposes a controlled paraphrasing framework to systematically generate natural prompt variations, addressing concerns about the stability and reliability of language model evaluations. The SciArena paper by Zhu and colleagues introduces an interactive framework for assessing and optimizing LLM-based psychological counselors, featuring realistic arena interactions, tripartite evaluation, and closed-loop optimization. These papers highlight the growing recognition that robust evaluation is crucial for understanding the capabilities and limitations of language models. Several groundbreaking results emerge from the papers we've analyzed. The VITA-Audio model introduced by Long and colleagues represents a significant breakthrough in multimodal language processing, described as the first multimodal large language model capable of generating audio output during the first forward pass, enabling real-time conversational capabilities with minimal latency. This achievement addresses a critical bottleneck in speech-based systems and could enable much more natural and responsive speech-based AI assistance. The ConfiDx model introduced by Zhou and colleagues addresses a critical gap in medical AI systems by explicitly identifying and explaining diagnostic uncertainties. This is described as the first study to jointly address diagnostic uncertainty recognition and explanation, substantially enhancing the reliability of automatic diagnostic systems. Yu and colleagues demonstrated that models trained using their long-short chain of thought mixture approach achieved an average accuracy improvement of 2.3% while reducing model response length by approximately 47.61%. The recall with reasoning method introduced by Ma and colleagues significantly boosted Mamba model's long context performance without requiring architectural changes. Finally, the SciArena framework showed up to a 141% improvement in counseling performance through reflection-based optimization. Several common methodological approaches emerge across the papers we've analyzed. Retrieval-augmented generation combines the generative capabilities of language models with retrieval mechanisms that access external knowledge sources. This methodology is particularly valuable for applications requiring factual accuracy and domain-specific knowledge. Chain-of-thought reasoning and knowledge distillation involve training models to generate step-by-step reasoning paths or to learn from the outputs of more capable teacher models. Parameter-efficient fine-tuning techniques, particularly quantized low-rank adaptation, CLORA, allow large pre-trained models to be adapted to specific tasks or domains with minimal computational resources. Mixture of experts architectures involve training specialized expert networks that each handle different aspects of the input, with a routing mechanism determining which experts to activate for a given input. Finally, interactive evaluation frameworks go beyond traditional static benchmarks to simulate real-world interactions and provide feedback for model improvement. Let's examine the VITA-Audio paper by Long and colleagues in more detail. This paper addresses the high latency when generating the first audio token during streaming, which has been a significant barrier to natural human-computer interaction through speech. The core innovation is the multiple cross-modal token prediction module, which efficiently generates multiple audio tokens within a single model forward pass. Traditional approaches generate audio tokens sequentially, with each token requiring a separate forward pass through the model. The MCTP module breaks this sequential dependency by predicting multiple tokens at once. The researchers developed a 4-stage progressive training strategy to train this module effectively. The experimental results are impressive. The model achieves an inference speedup of 3.5x compared to baseline models at the same 7B parameter scale. VITA-Audio is the first model capable of generating audio output during the first forward pass, dramatically reducing the perceived latency in conversational scenarios. Despite the focus on speed, it significantly outperforms open-source models of similar size on multiple benchmarks for automatic speech recognition, text-to-speech, and spoken question answering tasks. The paper Uncertainty-Aware Large Language Models for Explainable Disease Diagnosis by Zhou and colleagues addresses a critical gap in the application of large language models to medical diagnosis, the explicit identification and explanation of diagnostic uncertainties. While many AI diagnostic systems focus solely on making accurate diagnoses, they often fail to recognize and communicate when there is insufficient evidence for a definite diagnosis. The researchers developed ConfiDx, an uncertainty-aware LLM specifically designed for explainable disease diagnosis. They formally defined the task of uncertainty-aware diagnosis, assembled richly annotated datasets capturing varying degrees of diagnostic ambiguity, and fine-tuned open-source LLMs with diagnostic criteria. ConfiDx excelled in identifying diagnostic uncertainties, achieved superior diagnostic performance compared to baseline models, and generated trustworthy explanations for both its diagnoses and the uncertainties it identified. The researchers note that to their knowledge, this is the first study to jointly address diagnostic uncertainty recognition and explanation, representing a significant advancement in the field of AI-assisted medical diagnosis. The paper WebGenBench by Liu and colleagues introduces a novel benchmark designed to evaluate the capabilities of large language model-based agents in generating complete, functional websites from scratch. This research addresses the growing interest in using LLMs as code generation tools, particularly for complex, multi-file code bases like websites. The researchers created diverse instructions for website generation spanning 13 categories of web applications, from e-commerce platforms to data visualization tools. They developed an automated testing framework using a web navigation agent to execute test cases on the generated websites. The best-performing combination, Bolt.diy powered by DeepSeek R1, achieved only 27.8% accuracy on the test cases, highlighting the challenging nature of the benchmark. Fine-tuning Qwen 2.5 Coder 32B instruct on Bolt.diy trajectories achieved an accuracy of 38.2%, surpassing the performance of the best proprietary model. By focusing on end-to-end website generation rather than isolated coding tasks, WebGenBench provides a more holistic assessment of an LLM's ability to understand and implement complex software systems. Looking to the future, several directions emerge from the research we've analyzed. We can expect continued development of more efficient and responsive multimodal language models that can seamlessly process and generate information across not just speech and text, but also images, video, and other modalities. This will require innovations in model architecture, training methodologies, and evaluation frameworks specifically designed for multimodal tasks. We can also anticipate further development of uncertainty-aware and explainable AI systems, particularly for high-stakes domains like healthcare, finance, legal services, and education. Future research will likely focus on developing more sophisticated methods for uncertainty quantification, explanation generation, and human-AI collaboration. Finally, we can expect continued development of more efficient reasoning approaches for language models, balancing verbosity and accuracy to make reasoning more practical for real-world applications. In conclusion, our analysis of recent computational linguistics research reveals several important trends. Multimodal integration is advancing rapidly, with the VITA-Audio model demonstrating significant latency reduction for speech-based systems. Uncertainty recognition is proving crucial for trustworthy AI, as shown by the ConfiDx model in medical diagnosis. Evaluation methodologies are evolving beyond static benchmarks toward interactive, realistic frameworks that better capture real-world performance. These developments collectively point to a future where language technology becomes more multimodal, efficient, reliable, and capable of handling complex, domain-specific tasks. As these technologies continue to mature, they will likely have profound impacts on how we interact with computers, access information, and solve complex problems across various domains. This synthesis was created using multiple AI tools, including Anthropic's Claude 3.7 Sonnet 20250219 for content generation, Amazon Polly for text-to-speech synthesis, and Grok AI for image generation. All generated content was reviewed and curated by human experts in computational linguistics. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from ArXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.